All right, in this video, we're going to take a look at hyperbolas, which are going to be the last of the conic sections that we talk about. So a hyperbola is formed by taking two cones and inverting one of them and putting it, lining it up with the tip of the other. So here we have these double cones, and then taking a plane and slicing down the two cones to create something where you have part of the graph going upwards in this case, and the other part of the graph going downwards. A hyperbola is the reason why each of these pictures have two cones, but truthfully, the parabola, the circle, and the ellipse you could all get with just the bottom or the top cone. You don't need them both. With a hyperbola, you need both cones. So we're going to look at vertices, foci for hyperbolas in standard form. We'll also find the centers as well. In terms of this video, we're just going to look at the parts and the properties of them. And then in the next video, we'll look at some examples of actually using what we're going to learn in this one. So the mathematical definition of a hyperbola is a set of all points such that the difference of their distances from two fixed points called foci is constant. So it's the exact same definition as ellipses, but instead of the word sum of their distances, SUM, we have difference. So just like an ellipse, the midpoint joining the foci is called the center. And also, same thing with our vertices as well. The midpoint of our vertices is our center as well. And whereas ellipses could appear tall or wide based on which denominator is larger under what variable, hyperbolas are either going to open up and down like it did in the introduction slide, or open left and right. So a tall ellipse is akin to a hyperbola that opens up and down, and a wide ellipse is akin to a hyperbola that opens left and right. Now, there are going to be some subtle changes in this section compared to ellipses, but a lot of the things are going to be the same, but just a few minor changes. One of the differences is that hyperbolas that are open left and right, if the sign in front of the x variable is positive, and will open up and down if the sign in front of the y value is positive, regardless of the values of a and b. So with ellipses, we looked at the larger denominator, which told us is it going to be tall if the bigger denominator is below the y, or is it going to be wide if the bigger denominator is below the x. With hyperbolas, those denominators mean nothing. It's what's in front of our variables. So if x has a positive in front of it, but the y has a negative in front of it, even if the y has a bigger denominator, the x is the one that's positive, so our hyperbola would open left and right. So here, speaking of, we have a hyperbola that opens left and right. We have the center. Here's our two vertices of our hyperbola. It resembles two parabolas, in this case, back-to-back parabola. Well, not really back-to-back, but two parabolas, one opening left, one opening right. So here we have our vertex for, these are called branches of the hyperbola. So the vertex of each branch. And notice our focus point with ellipses, our ellipse would have been inside this box. With hyperbolas, the hyperbolas are outside the box. So we're literally going to be thinking outside the box. Our focal points are C units away from the center, just like our vertices are A units away from the center. And like parabolas, our focal points are going to be inside the branches of the hyperbolas. So again, you could think of each branch is like a cup, and then the focal points, the foci, are inside the cup, like an ice cube floating in water. The value of B will determine in this case, the height of these boxes. And again, with ellipses, we could draw this rectangular box. Ellipses would go inside the box. Hyperbolas go outside the box. And so what we're going to do to graph them is we're going to sort of sketch out this box and then draw diagonals, and then let those diagonals guide our hyperbola's branches. So with opening left and right, your x minus h in parentheses squared over a squared, it's positive, minus y minus k squared over b squared equals 1. This is our standard form, opening left and right. So because the minus is in front of the y, that's automatically going to make our hyperbola open left and right. Our center is still hk, vertices still h plus or minus, this should actually be a k here, and same with the foci, should be a k, not a 0. Foci still h plus or minus c, so the center, vertices, and foci, those concepts haven't really changed at all. Same with the covertices. We have we're adding and subtracting b from the y value here for our covertices. So the vertices and covertices help determine the length and width of this rectangle that we'll use to help graph our hyperbola. The left and right, the axis that's going left and right, the one that contains the foci and the vertices, that axis is called the transverse axis, and then perpendicular to that is the conjugate axis. So with ellipses, we said the axis that contains the vertices and foci is called the major axis, and the axis perpendicular to that would be the minor axis. With hyperbolas, the major axis is the transverse axis, and the minor axis is the conjugate axis. And another important difference with hyperbolas, when we essentially just change the plus to a minus in the equation, it also changes how you find the value of c. So in this case, for hyperbolas, we're not going to subtract a squared and b squared to get c squared. We're going to add them. So other than that, there's a lot of similarities between ellipses and hyperbolas. So again, the vertices and foci, these should be a k, a value of k. If it's opening up and down, this is the equivalent of a tall ellipse. So here's our center, and our vertices are a units away from the center. Our foci are c units away from the center. Here I just have it, I had it centered at the origin, so that explains why that is. Our covertices are going to be left and right. And our equation this time, if it's going up and down, is, notice the positives with the y, and now the negative is with the x. So we have y minus k in parentheses squared over a squared minus x minus h in parentheses squared over b squared equals 1. Pretty much everything else the same. The covertices here should be plus or minus b, so I apologize for that. Plus or minus b. Now going up and down is your major axis or your transverse axis, the hyperbolas form of that. And left and right is the conjugate axis, so the conjugate axis contains the covertices. The transverse axis contains the foci and the vertices. And then again, c squared is a squared plus b squared. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.